Chapter 1, Section 1, Rotational Motion is the title. Now, first we are going to define what rotational motion is. When an object spins, it is said to undergo rotational motion, like this. This object is spinning, so then we say that this object is in rotational motion. So when an object is spinning, there is a point about which all the points or the object is rotating. So this point is known as, or this line is known as axis of rotation. So the line about which the rotation occurs. Normally, this in two-dimensional surface, it seems to be a point. However, in three dimension, it's a line. So because it's in vertical, it's a line. About this line, the object is rotating. So for that reason, this point, which is almost the center of the rotation, maybe we can say like this, the line about which the rotation occurs is called axis of rotation. Right here, there's a line. This line is said to be the axis of rotation. So there is another object which is known as the symphony swing. So about which line rotation occurs? This line. So this is the axis of rotation for symphony swing. However, when an object is rotating, the points on the object, any point on the rotating object undergoes circular motion. So why is it like this? Because when this object is rotating, if you take this point makes a circle, moves in a circle. And if you put a line right, a pen or pencil at this point, this pen or pencil will draw a line, a circular line. For that reason, we did that any point on a rotating object undergoes circular motion. So why? Because it draws a circle. For example, Ferris wheel is a rigid object. So this rigid object is rotational motion. The Ferris wheel is a rigid object. It is in rotational motion. But any point, for example, the cabins right here, these cabins are drawing a circle. For that reason, the cabins are in circular motion because the cabins are just some points, a point on this rigid rotating object. For that reason, this point is making circular motion. That is the difference between rotational motion and circular motion. Simply, we can say that the rigid objects rotates, but any point on that rigid object circles. So a rigid object is in rotational motion. Any point on that rigid object is in circular motion. So now we are going to define the circular motion, so rotational quantities. For example, assume that initially an object, a point on a rotating object right here. Initially it is here. But later, this object is starting to rotate from this point to another point. So initially it was here, then it's somewhere here. It's somewhere here. So then we should define first the position of the line. How can we define the position? In linear motion, we define by distance. However, in rotational motion, object is continuously moving on the same circle. For that, as in, you cannot define the position by a distance. Instead, we are going to define the position of the object by an angle. For example, initially, this is the position of the object. So, remember, to study the motion, we should first define a reference point in the linear motion. But in rotational motion, we are going to draw a reference line. So, according to this reference line, we are going to define the position of a point on an object. So, then this is the point A. We draw a position line. So this is the reference line according to which we are going to define the position. So the angle between these two lines will be position, angle for position. So they determine the measure of the direction of the angle between the reference line and the position line. So this angle is the position of point A with respect to that reference line. So however, this angle, when this angle increases, that distance also increases. That distance is known as arc length. So there must be a relation between the arc length and the angle. The part of a circle or a curve correspond to the angular quantity theta is called the arc length. So this is the angle, that is the length, arc length, corresponding arc length for this angle. So this relation is this. When, for example, this is angle theta, so R1 is the radius of the first arc length, R2 is the radius of the second arc length. As you see, second arc length is longer than the first one because second one is a longer radius than the first one. For that reason, we can say that if the radius of the circle increases, arc length also increases. Shorter radius, shorter arc length. Longer radius, longer arc length. And the ratio of arc length to the radius gives a quantity. That quantity is the angle theta. So if we divide S1 by R1 or S2 by R2, we will get a quantity which is theta. So in general, theta is equal to arc length divided by corresponding angle. So it is, arc length divided by radius, it is the corresponding angle theta. So, however, this theta is in radian, calculated in radian, not degree. So the above equation is one of the basic equations which relates to linear and angular quantities. Why? Because distance, arc length is the length, it's a linear quantity, but theta is an angular quantity. So this equation is making a relation between linear and angular quantities. So theta is often measured in radians rather than degree. Yes, in this equation, theta is equal to S divided by R. We are going to define measure the angle theta as radian, not degree. So then we should define what radian is. The angle whose arc length S is equal to its radius R is measured 1 radian. So then this distance and that distance, if they are equal to each other, yani arc length S and radius R, if they are equal to each other, then this angle is equal to 1 radian. How? Let's give some numbers. Say that arc length is 5 meters. In this case, radius must be 5 meters. So then we can say that this angle is 1 radian. Or if say that S is equal to 7 meters, so radius must be equal to 7 meters too. In this case, I say that angle is 1 radian. So 1 radian is approximately equal to 57.3 degrees. So that 1 radian is equal to 57.3 degrees. So this information is asked twice times in ministry exam questions. 1 radian is equal to how many degrees? 57.3 degrees. Radian is a pure number with no dimensions. What does it mean? Radius is equal to S divided by R. So S is length, arc length. Radius also length. So when you divide them, so as you see, no dimension, they simplify. For that, as in radian is pure number. So for one complete revolution, the arc length is 2 pi r. So if say that object start from this point and rotates and comes to the same point again, it travels a distance which is the circumference of the circle, and it is equal to 2 pi r. By the time the object rotates an angle of 2 pi, because this one complete rotation is also equal to in angle 2 pi radian. For one complete rotation, the corresponding angle is 2 pi radian. So arc length is 2 pi r, angle is 2 pi. 2 pi is equal to in degree 360. So for one complete revolution, arc length is 2 pi r, angular displacement or change in angle is 2 pi in radian or 360 in degree. So then by using these two relation, I can make an equation. If 2 pi radian is equal to 360 degrees, Pi radian is equal to 180 because you are going to divide it by 2. So pi, to simplify, pi radian is equal to 360 divided by 2, 180. So by using this equality, when pi radian is equal to 180, we can calculate the corresponding radian of a degree or corresponding degree of a radian. So then radian in degree, angle in radian is equal to angle in degree cross multiply them. So theta in degree times pi, theta in radian times 180 is equal to theta in degree times pi. So if you want to calculate the radian, divided 180, divided 180. So radian is equal to pi divided by 180 times degree in radian. So by this equation, you can calculate, you can convert degree to radian or radian to degree. So degree to radian is this. If you want to calculate the radian to degree, only thing you should do is multiply this, cross multiply it, multiply by 180 divided by pi, which is equal to angle in degree. So from radian to degree you can convert by this way. Okay, for example, convert the following angles in degrees to radian, which is 35 degrees and 128 degrees. So simply you are going to write here 35 angle in radian is equal to, so pi is 3.14, everybody must know this, pi is 3.14 divided by 180 multiplied by 35 degrees. So when you multiply them, answer is 0.61 radian. This is one way, but some students are doing this way. This is the equation in your book, but also you know what is the corresponding degree for 1 radian. 1 radian is equal to 57.3 degrees. So you will calculate 35 degrees, how many radian. This cross multiplication also can be done. X times 57.3 is equal to 35. So divide by 57.3, divide by 57.3. So simplify them, you get the same answer as 0.61 radian. This is another way for answering the or converting the angle to radian or radian to degree to radian or radian to degree. Okay, and the other thing is we are going to define, in fact we defined the angular displacement. Initially assume that the object is, the point on the object is here, but the object is starting to rotate, point also rotating by a distance of delta s. This is the angular displacement, this is the arc length, corresponding arc length, don't forget. So object is rotating by an angle of delta theta. This delta theta is known as the angular displacement. Why? Initially angle was theta 1, final angle is theta 2. Is there a change in angle? Yes. That is why we say it's delta. Delta represents the change. So angle is changing. This change in angle is known as angular displacement. The angle through which an object is rotated is in a specific direction is called angular displacement delta theta. So because there is a relation between s, theta and r, there's also the same relation between delta theta, delta s and r. R is constant for a rigid object, so it is, if it is 10, always 10 because it's rigid. For that is no delta for r, but arc length, as arc length changes, theta also, delta theta also, angle is also changes. For that reason we are going to write delta theta. And change in arc length and change in change in the angle or the angle which is called angular displacement are proportional. So if delta s and delta theta are considered positive for counterclockwise rotation, if the object is rotating counterclockwise, so we assume that delta theta is positive, delta s is positive, delta theta is positive. If object is rotating clockwise, in this case both are negative. The negative will be written as negative. For example, sample problem. Shahzad writes on a coruscant that is rotating clockwise. Yeah, clockwise rotation is, remember, negative. He travels through an arc length of 11.5 meters. So arc length is represented by delta s. So it is clockwise, so negative. Delta s is negative 11.5 165. If the child's angular displacement is 165 degrees, so angular displacement is delta theta. It is negative y because clockwise. Delta theta is negative 165 degree. Calculate the radius of the carousel. So what is r? First, we should convert degree to radian because we are not going to do any calculation with degree. So radian is equal to pi over 180 multiplied by theta in angle in degree. So pi is 3.14 divided by 180 multiplied by the angle negative 165 degree. So is corresponds to an angle which is negative 2.88 radian. Now it's time to calculate r. Because delta s is equal to delta theta is equal to delta s over r, cross multiply them. So r is equal to delta s divided by delta theta. So we can do it like this. R times delta theta is equal to delta s, cross multiplication because here is 1. So divide by delta theta, divide by delta theta. So simplify them. So then r becomes delta s over delta theta. So delta s is negative 11.5. So delta theta is equal to negative 2.88. When we divide them, reduce. Practice problem 1. Abedul sits at the top of a bicycle wheel and flies away just before it would be squashed. If the wheel turns clockwise, so clockwise is negative, and the Beetle's angular displacement is pi radian, angular displacement is delta theta, it must be pi radian. Pi radian is 3.14. Pi is 3.14 radian. And corresponding arc length, yani delta s is, because it is negative we are going to write, negative 1.2 meters. So what is the wheel's radius? Calculate r. So equation for calculating r is this. Because delta theta is equal to delta s over r, so cross multiply, take r here, delta theta there, r is equal to delta s over delta theta. Then calculate r. Delta s is negative 1.2 meter. Delta theta is given in radian, great. It must be in radian in calculation. Don't forget, never use degree. So answer becomes, in this case, 0.38 meter. So fill in the unknown quantities in the following table. Next practice problem. So r is given, delta s is given, calculate delta theta in radian. Equation is known, delta theta is equal to delta s over r. All numbers are given. Delta s is positive 0.25, r is 0.1. When you divide them, answer becomes 2.5 radian. That is the angular displacement in radian. Right here, angular displacement is given, r is given, delta s must be calculated. Cross multiply them simply. So delta s is equal to r times delta theta. So r is given as 8.5 multiplied by delta theta 0.75. So multiply them and get the answer. Next one, C. The angular displacement is asked, but in degree it is asked, not radian. But first calculate it in degree, after that calculate in radian, because division of delta s to r will give us not degree, it will give us radian. Delta s is negative 4.2 divided by delta r is 0.75. When you divide this, you will get a number. So then after that, convert this number, this is in radian, to degree. So you will get blah 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 radian is equal to how many degree, because question is asking you to find the angular displacement not in radian, in degree. Following physical quantity in rotational motion we are going to define is angular speed. In fact, we know what speed is. If an object moves on a distance delta s in a time delta t, it is called this speed of that object. Distance divided by time is speed. So in rotational motion, distance is arc length, delta s. If we divide delta s by delta t, we will calculate the linear speed of that object. However, we should define the speed in terms of angle too, because we know also there is angular displacement. If the rim rotates an angle of delta theta, an angular displacement of the object is delta theta in a time interval delta t, another type of speed may be calculated by using the angular quantities. That speed is known as angular speed. So average angular speed is defined as the rate at which a body rotates about an axis. When it says rate, you will understand it is it's related to time, something related to time. So in a shorter time, rate is big, in a longer time, rate is small. So when we divide the angular displacement delta theta by time, we will find the average angular speed. So angular displacement divided by time is the average angular speed. Angular speed is a symbol of omega. Omega average is equal to delta theta divided by delta t. So unit of average angular speed is radian. Why? Because delta theta is written as radian. Delta t is written as second. In this case, radian per second is the unit of angular displacement. However, some questions you are going to see it is as revolution per second too. But in calculation, you never use revolution. You should convert it to radian per second. How? We know that one revolution is 2 pi radian. Remember, when object rotates once, it is 2 pi radian. One revolution is 2 pi radian, which is 360 degrees, remember. So 2 pi radian is equal to 2 times 3.14, because pi is 3.14, which is equal to 6.28 radian. So one revolution is equal to 6.28 radian. Don't forget this. If it is 2 revolutions, 2 times 2 pi, which is 4 pi radian. So twice of that number is the 2 revolution. It's 3 times 3 revolutions, 3 times 2 pi radian, yani 3 times 6.28. If 4 revolutions, 4 times 6.8 is the angular displacement. For example, Razgar spins on a stool in counterclockwise direction, positive counterclockwise, with an average angular speed of 4 radian per second. So it is positive for that, isn't it? In what time interval will Razgar fit have an angular displacement as 8 pi radian, delta theta? So in what time interval? Delta t is the question. In what time interval? So this is the average angular speed, 4 radian per second. So this is the angular displacement, delta theta. So average angular speed is 4 radian per second. Delta theta is 8 pi. Calculate delta t. So average angular speed is equal to delta theta divided by delta t. Because we will calculate delta t, cross multiply them. Delta t is equal to delta theta divided by v average. So how can delta theta is how much? 8 pi. Pi is how much? 3.14. 8 times 3.14 divided by average angular speed is 4. So this answer is 6.28 second is the time it takes for that angular rotation, angular displacement. Another question, a car tire rotates with an average angular speed, average angular speed, omega average. In what time interval? What is the question? Delta t. The tire rotates 3.5 times. 3.5 times, which means 3.5 revolutions. When it says times, you will understand it is revolutions. Let's write them. So this is the angular displacement, 3.5 revolutions. Delta theta, because it is, rotation is 3.5 times, I'm going to write 3.5 revolutions for delta theta. So average angular speed is 29 radian per second. Calculate the time interval delta t. So what is the equation for average angular speed? Average angular speed is equal to delta theta divided by delta t. So cross multiply them, delta t, simply change their okay, positions. Delta theta divided by omega average. So delta t is equal to delta theta is how much? 3.5 revolutions, but every revolution is how many radian? 6.28. For that, you should multiply and then convert it to radian. And 3.5 revolutions equal to 3.5 times 6.28 radian. So that is the answer in radian. Divided by average angular speed, 29 radian per second. So answer becomes 0.76 second, if you do like this. Other questions are also very easy. Just it's asked here, calculate the average angular speed. So delta theta divided by delta t. Delta theta is given as radian, so no problem. 2.3 divided by time is given in second, no problem. So 0.23 radian per second. Second one, average angular speed is given radian per second, no problem in the unit. Time is given in second, no problem in the unit. So calculate angular displacement delta theta, cross multiply them. Delta theta is equal to omega average times delta t. Omega average is 0.75 positive. Don't forget to write the sign. 0.05 multiply them. Most probably it is 0.037.5, something like this, radian. So next one is ask average angular speed, but this time it is given in revolution. Remember, I told you that with revolution you cannot do a calculation. You should convert revolution to radian. How? By multiplying 6.28, because every revolution is 6.28 radian. So divided by time is 1.2 second. It is negative 6.28 radian per second. So next one is average angular speed is given. Angular displacement is given. Calculate delta t. Delta t is equal to, from this, delta t, delta theta divided by omega average. Delta theta, how much is delta theta? 1.5 pi. Right here, no need to write the pi 3.14 because they will simplify. I can see them because both contains what? Pi divided by 2 pi. Now we can simplify pi without writing 3.14. So it is 0.75 second is the answer. So this is the answer of this question. But now we define the average angular speed if the speed is assumed to be constant, but sometimes speed is not constant. Object can speed up or slow down like this. So it is speeding up or slowing down. So in this case, you need to calculate an acceleration, because if the speed of an object is changing, so the object has an acceleration. In linear, we defined this before. But now we are going to define the acceleration in angular form. In fact, definitions are no different than the definition of the linear acceleration. Remember, in linear, if the linear speed of an object changes by time, linear acceleration is calculated. And linear acceleration A is equal to change in the speed of an object, delta V, divided by change in time. So the rate of change in the speed of an object is called the linear acceleration. Right here, we are going to define the angular acceleration according to rate of change in angular speed, because angular speed is changing. If the angular speed of an object changes by time, how? So speeding up or slowing down in this case, so we can calculate the change in angular speed. If the angular speed of an object changes by time, the average angular acceleration is calculated. Average angular acceleration is alpha. Now, linear acceleration is A, angular acceleration is alpha. They are not, it seems to be the same, but they are not. One of them is alpha, the other one is A. So alpha can be calculated by change in angular speed, delta omega, divided by change in time, the time delta t. So change in angular speed can be calculated by omega final, angular speed final minus angular speed initial. Change in time is calculated time final minus time initial. Then average angular acceleration is the rate. Yes, because there is a time. When there is a division as time, it is a rate. Rate of change of an angular speed. Yes, angular speed changing, which is expressed in radian per second per second. Why? Because this is radian per second. Once again divided by per second. Radian per second, which is radian per second squared. It's called the average angular acceleration. So let's solve a problem. A car's tire rotates at an initial angular speed. Yes, there is an initial angular speed. How much? 21.5 radian per second. The driver accelerates. Yes, there's an acceleration. And after 3.5 seconds, it is time interval delta t. After 3.5 seconds, the tire's angular speed, once again, but because it's after, it is final. Final angular speed is 28 radian per second. What is the tire's average angular acceleration? Calculate alpha average. During this 3.5 second time interval. We said its time interval is 3.5 seconds. So initial angular speed is 21.5. Time interval is 3.5 seconds. Final angular speed is, it is 28 radian per second. Calculate the average angular acceleration. Average angular acceleration is change in angular speed divided by time. So change in angular speed is final minus initial. Time is delta t. Time interval is delta t. Final angular speed is 28. Initial angular speed is 21.5. Time interval is 3.5 seconds. When we divide them, we get the answer as positive. So this positive represents that it is speeding up. Yani the angular speed of the object is increasing. Okay, fill in the unknown quantities in the following table. It says, again very easy, average angular speed must be calculated by equation change in angular speed divided by time interval, change in angular speed 121.5, time is 7. When you divide them, you will find the answer in radian per second squared. This time average angular speed is given, change in angular speed is asked. So cross multiply them, calculate delta omega, which is average angular speed multiplied by delta t. Average angular speed 0.75 multiplied by delta t 0.05. So answer is radian per second. So right after that, we find the c, which is average angular acceleration, again must be calculated. It is change in angular speed divided by time interval. Change in angular speed is negative 1.2 revolution per second. Again, revolution. Every revolution is 6.28 radian. Don't forget, we should always convert revolution to radian. Divided by time interval 1.2 seconds. So you will find the answer in radian per second squared. And one last thing about the rigid object rotating on a rotating spinning rigid object. Now, in this rigid object, every point here, every point is rotating with the same angular speed, rotating with the same angular acceleration, rotating with the same angular displacement. Yani all angular quantities on a rigid rotating object are the same. This is one of the ministry exam questions, don't forget. So, if the object is rigid, on this object, every point will move with the same angular speed, with the same angular displacement, with the same angular acceleration. So, for a rigid object, angular displacement delta theta of all points are equal. Angular speed omega of all points are equal. Angular accelerations of alpha of all points are equal. Don't forget this. Okay. Next title is we're going to now compare the angular and linear quantities. As I said, rotational motion, linear motion, a different form of motion. In linear motion, we are moving on a line. In rotational motion, the object is moving on a circle. That is the only difference between them. But the equations are almost the same. For example, in linear motion, we can find, if the linear motion with a constant acceleration, we can find the final speed with initial speed plus acceleration times the time it takes for the acceleration. In linear angular form, instead of v final, we are going to write omega final. Instead of v initial, we will write omega initial. Instead of linear acceleration, we will write angular acceleration. Time is the time. Second equation for calculating the displacement. Delta x is equal to initial speed times delta t plus 1 over t a delta t squared in the linear form, angular form. Linear displacement, angular displacement. Linear speed, initial angular speed. So linear acceleration, angular acceleration. So as you see, equations are almost the same. Displacement is equal to 1 over 2 initial speed plus final speed multiplied by delta t. So linear acceleration, linear displacement, angular displacement. Linear initial speed, angular initial speed. Linear final speed, angular final speed. So this is third equation. Final speed squared is equal to initial speed squared plus 2a delta x. So here is a is the acceleration linear, delta x is the displacement. So in angular form, in linear final speed squared, angular final speed squared, linear initial speed squared, angular initial speed squared, linear acceleration, angular acceleration, displacement, linear, angular displacement. So in these equations, they are very similar to the equation. They can be used for answering the questions. The quantity omega represents instantaneous angular speed rather than average angular speed here. So instantaneous angular speed means the speed, angular speed at that instant, at that time. So at t is equal to, for example, 0.1 second. It does not refer at interval because interval is delta t, don't forget this. Okay, now let's solve some problems. The wheel of an upside down bicycle moves through 11 radian in 2 seconds. So moves through 11 radians says angular displacement delta theta. How many seconds? In 2 seconds delta t. What is the wheel's angular acceleration? So what is the wheel's angular acceleration? Yani alpha. If its initial angular speed is 2 radian per second. So initial angular speed is omega initial is 2 radian per second. Now given delta theta 11 radian, delta t 2 second, omega initial 2 radian per second. Calculate alpha. So the second equation, delta theta is equal to omega initial delta t plus 1 over 2 alpha delta t squared can be used because we know what delta theta is, we know what initial angular speed is, we know what t is, we can write it there, just one unknown which is alpha. So we write them, 11 is delta theta, initial angular speed is 2, time interval is 2, 1 over 2 alpha must be calculated, time interval 2, square of 2, so answer becomes in this form, it's 3.5 radian per second. Next practice problem. A remote control car's wheel accelerates at, yes, given, accelerates at its angular acceleration alpha. How much? Positive 22.4 radian per second squared. If the wheel begins with an angular speed, yes, begins angular speed, which is omega initial, of course. Omega initial is equal to 10.8 radian per second. What is the wheel's angular speed? Yani omega final is asked to you. After exactly 3 full turns, 3 full rotation, 3 revolution, yani delta theta. Delta theta is given as 3 revolutions. Don't forget, every revolution must be converted to radian. So it is 3 times 6.28 radian. So for answering this question, we are going to use equation, the fourth one, because in this given there is no time. There is only one equation which without time. It is the fourth one. Final speed squared is equal to initial speed squared plus 2 alpha delta theta. Final is question. You will find it. Initial is, yes, final speed squared. Initial is 10.8 squared plus 2 alpha 22.4. Delta theta 3 times 6.28. When you do this calculation, you will get the answer as omega final 31 radian per second. So question says in part, second question, how long does it take? How long does the well in item 1 take? It says delta t. How long? When it says it is delta t. To make 3 turns. And for that 3 turn, what is time? And now we can use one equation because we know what initial and what final is. This equation is enough. Final speed is equal to initial plus alpha delta t, because final is 31, initial is 22.4, alpha is given 22 initial is 10.8, final is 22.4, calculate delta t. So right after that, delta t is equal to 0.9 seconds. Now, question number, section review questions. A mosquito lands on a phonograph record 5 centimeters from the center. So radius is 0.5 centimeter, but must be converted to meter, 0.05 meter. If the record turns clockwise, negative, so that the mosquito travels an arc length, delta s. What is the angular displacement? Delta theta. So delta s is given because clockwise rotation it is negative 0.05 meter again. So what is the angular displacement? Delta theta. Delta theta is equal to delta s over r. Delta s is negative 0.05. R is 0.05. When we divide them, it is negative 1 radian. This is the angular displacement. Question number 3. A cyclist rides along a circular track. If the cyclist travel around exactly half the track, half revolution, yani 0.5 revolution. In how many seconds? Delta t. So this is delta theta, 0.5 revolutions. This is delta t. What is the average angular speed? Omega average. So delta theta angular displacement is half the track, means half revolution, because full track is 1 revolution, half track, half revolution. Half revolution is 0.5 revolution. Delta t is equal to 10 seconds. So calculate omega average. Okay, so omega average is equal to delta theta divided by delta t. Delta theta 0.5 revolution, but every revolution is 6.28. So you should convert the revolution to radian by multiplying 6.28 divided by time interval 10. So answer becomes 0.314 radian per second. Next one, find the angular acceleration. Find the angular acceleration alpha of a spinning amusement park ride. Initially travels at this speed, initial speed. When they accelerate and then accelerates to final speed. Accelerates to final speed. During 0.5 second time interval, delta t. All are given as this. Just simply you are going to write them and calculate them. So omega initially is given as 0.5 radian per second. So acceleration is given as 0.6 radian per second square. And accelerates to final speed is given as 0.6 radian per second. Time interval is given as 0.5 second. Calculate the average acceleration. So what is the equation? Delta omega over delta t. What does it mean, delta omega? Final minus initial divided by delta t. Final is how much? 0.6. Initial is 0.5. Time interval is 0.5. When you do this, answer is 0.2 radian per second squared. And one last question. What is the instantaneous angular speed of a spinning amusement park ride? that accelerates from, yani initially it is 0.5 radian per second at a constant angular acceleration. Yes, angular acceleration alpha. For 1 second, delta t is equal to 1 second. What is the instant angular speed? Which is final, it's asked. How do I know it's final? Because it accelerates from 0.5. From 0.5 means initial is 0.5. So initial angular speed is 0.5 radian per second. So the angular acceleration is 0.2 radian per second squared. Even look at the units, you can understand if the squared is angular acceleration. Time interval is 1 second. Calculate the final. So final is equal to initial plus alpha delta t. Initial is 0.5 plus alpha 0.2 delta t is 1 second. So answer is 0.7 radian per second. This is the answer of this question.